Let's find all the solutions to the equation cotangent squared of x equals 3 times cosecant x minus 3. Okay, I'm going to use my Pythagorean identity for this cotangent squared of x and replace it with cosecant squared x minus 1. That is convenient because now the only trig function I'm really dealing with is cosecant. Okay, this looks like a quadratic, so I'm going to get everything on one side. Cosecant squared x. If I subtract 3 cosecant x from both sides, I get minus 3 cosecant x. And I add 3 to both sides, plus the negative 1, just plus 2. Okay, so now cosecant squared x minus 3 cosecant x plus 2. If it helps, you could think about this instead as x squared. Trying to fill this all in. So x squared minus 3x plus 2 equals 0, right? You can think about it like that. You're trying to factor this expression, which factors to be x minus 1, x minus 2. Set them both equal to 0. Now x is a poor choice. I should use another letter here instead of x because I don't want all these x's all over the place. Okay, so let's use y instead. There we go. Y. Okay, so y minus 1 times y minus 2 equals 0. So the zero product principle says that y minus 1 equals 0 and y minus 2 equals 0. So y equals 1 and y equals 2. Now, what does this really mean? Well, remember, y was just a placeholder for cosecant. Cosecant of x equals 1. Cosecant of x equals 2. Now, typically, we don't remember cosecant off the top of our heads. So what we'll do is we'll rewrite this as its reciprocals. For instance, if I flip this one over, sine of x is equal to 2 is understood to be 2 over 1. That flipped over is just 1/2. And this one here, if I flip that one over, I get sine of x. And the reciprocal of 1 over 1, is just 1, right? So that one actually doesn't change really anything. All right, so on my unit circle, I want to find where y is 1. Well, that happens at pi over 2. I also want to check where sine, or y, is 1/2. That's at pi over 6. And 5 pi over 6. So those are going to be my answers. X is equal to pi over 6, pi over 2, and 5 pi over 6.